Hi everyone. This is chapter 6, and if you're looking at these slides, that means you've finished the second midterm. Congratulations. So this chapter is about derived random variables, situations where given random variables x and y, you might, for instance, calculate w is g of x and y, and you might like to be able to derive the PMF of W or the CDF of W or the PDF of W. And of course, it's important to notice that this case of W is G of XY. It includes the special case where W is just a function of X or W is a function of Y. So we'll start with the simplest case where we have discrete X and Y with some kind of a joint PMF, and we form W is some function of X and Y. And since X and Y are discrete, the set of possible values for W is also a discrete set. And so W will be a discrete random variable. And so we'd like to find its PMF, PW of W. Like most things with discrete random variables, the PMF of W is found by a bookkeeping theorem. Since W is G of XY, then W is equal to W if and only if G of X and Y is equal to W. So we find probability that W equals W is the probability that G of X and Y equals W. And essentially, this theorem does the bookkeeping that says we look for all the x and y pairs, such as g of xy equals w, and then we add up those probabilities, and that's how you get the probability w is equal to some small w. Since this might not be clear, let's do an example. In this problem, the joint PMF of x and y is given for values of x ranging from -2 to 2 and values of y from -1 to 1. But the formula has an absolute value and a division by 14, and it's not so clear what's going on. And in this case, the best thing to do is to draw a nice XY plane and identify the points with non-zero probability. So in fact, the x's are -2, 0, and 2, and the values of y are -1, 0, and 1. And so we get these 9 points where this corner point, for instance, this boundary is 2, this is -2, and this is 1, and this is -1. The next step is to label these points with their probabilities. For instance, x equals at x equals 2 and y equals 1, we get from the PMF that x plus y over 14 is equal to 3 over 14. Similarly, at x equals 2 and y equals 0, we get 2 over 14. And x equals 2, y equals -1, we get 1 over 14. And the other probabilities are y is 1 and x is 0. This is probably 1/14. X and y equal to 0. This is actually 0 over 14. We can leave it in, but in fact, that point doesn't have any probability. And finally, x is -1 and y is 0. there's an absolute value sign around the x plus y, so this is 1 over 14. And back here on the left side, we have in the lower left corner, x is minus 2, y is minus 1, the sum is minus 3, but there's an absolute value sign, so we get 3 over 14. And here we get 2 over 14 and 1 over 14. And if you check, these probabilities should add up to 1. The next step is to label each of these points with the value of w equal to x minus y. So for instance, in the upper right-hand corner, x is equal to 2 and y is equal to 1. So x minus y is w equals 1. And the next point here, w is equal to 2. And now when x is 2 and y is negative 1, w equals 3. Similarly, the other points are x is 0, y is 1, w is minus 1, w equals 0. This point will turn out to be irrelevant because x and y 0, 0 doesn't have any probability. And finally, w is equal to 1 because x is 0 and y is minus 1. And on the far left, we have w is equal to minus 2 minus 1, which is equal to minus 3. Here, w is minus 2. And finally, in the lower left corner, we have x is minus 2, but it's minus negative 1, and we get w is negative 1. Now we can make up a list of probability facts we see using the theorem. For instance, the probability that w is equal to minus 3 is 1/14th. And this fact comes from looking and seeing w equals 3 occurs only here, and its probability is 1/14th, and that corresponds to this fact. Similarly, the probability w is equal to minus 2 is 2/14ths, because that corresponds to this is the only xy pair that generates w is minus 2, and its probability is 2/14ths. Moving on, we have the probability w is minus 1 is equal to 3/14ths plus 1/14th. And this corresponds to this possible xy pair generating w equals minus 1, and this xy pair generates w equals minus 1. And together you get probability w equals minus 1 is 4/14ths, or 2/7. So this is a good example of how to find the probability w equals minus 1, we find all of the xy pairs such that the function of x and y, this g of xy, is equal to that value of w, in this case, minus 1. So to finish up this process, we just observe that the probability w is 0, and so we could have left this out. The probability w is equal to 1 is 1/14th plus 3/14ths, also 2/7. And that reminds me I should have labeled this 2/7. The probability w is 2 is 2/14ths, and the probability w is 3 is 1/14th. And finally, if you want to be neat and tidy, you write this as a nice PMF, and it's equal to 1/14th at w equals minus 3, 2/14ths at w equals minus 2, 2/7, 4/14 at W equals -1. And I suppose we could just repeat these. It's also 2/7 at W equals 1, 2/14 at W is -2, and 1/14 at W equals 3. And this -2 should be a +2. And of course, we should put in a 0 otherwise to finish the problem. If my solution seemed confusing, this slide and the next slide have the same solution as given in the solution manual. And essentially, it's the same thing, maybe a little neater and tidier. So the problems of this section are all essentially similar bookkeeping problems. And so we're done section 6.1. So let's stop here.